and welcome to the Pedagogic Table. Carbon has been known since prehistoric times. Its name comes from the Latin word carbo, meaning charcoal. It is the sixth element in the periodic table. Carbon is unique because of its 4 valence electrons and characterized by its ability to form strong covalent bonds with carbon atoms and other elements.
Okay, now we're going to look at another element, carbon. Now, carbon is very, very good at producing energy for man's energy needs. So what we have here is we have basically a steam engine, although it looks like a fire truck. What we're going to do is we're going to use these pellets. You may think of these as actually being carbon, although actually they're a compound of carbon. They're a hydrocarbon containing the element C, carbon. There's too many carbons. So what I'm going to do here is I'm going to warm them up and get them burning, and then I'm going to place them inside this fire truck. What this is going to do then is the energy from the hydrocarbon, from the carbon, is going to be used to raise the temperature of the water, and then it's going to drive the engine. So first of all, we're going to heat these. We'll get them burning, as you'll see here. Like most things containing carbon, this is very flammable. Here we go. Here's number 1. And here's number 2. We've got these burning. Put these inside, and then we simply have to wait until the pressure builds up. Okay, so here we are a few minutes later. We've allowed now the hydrocarbon, the energy from the hydrocarbon, to heat the water. And now if I just press this little lever here, you'll see there's quite a pressure of steam. Now what's going to happen now is I'm going to show that this steam can be converted into mechanical energy to drive this fire engine here. So first I have to make sure the steam can flow to drive the piston up and down, and then I'm going to engage the gear, and you'll see the fire truck move slowly forward as the energy from the chemical energy from the coal is converted first to steam and then to mechanical energy.
Pure carbon is found in the Earth's crust as graphite and diamonds. In its bound forms, it's found as fossil fuels. Carbon as diamonds is rare, but can be found in volcanic canals. Of 13.5 million compounds, 94.4% of these are carbon compounds. Such quantities required its own name. That's why we call the study of carbon compounds organic chemistry. Carbon can be found in nature and acquired in mines. Carbon as diamonds can be artificially manufactured, but the result is of worse quality than the naturally occurring ones.
Okay, so what we're going to do now is we're going to do another investigation of the element carbon. Now, all living organisms are rich in the element carbon, and all living organisms contain things such as protein, sugars and fats. So here I've got normal sugar you buy from the supermarket. This is actually sucrose, a disaccharide sugar, and it's rich, like all sugars, in the element carbon. So what I'm going to do is I'm going to add some sugar into this little glass container here on the front. And what we're going to do is we're going to add some concentrated sulfuric acid. Now, concentrated sulfuric acid has the effect of actually carbonizing. It actually turns the sugar, or dehydrates it, into the element carbon. So Here's the concentrated sulfuric acid. Has to be very, very careful this. This is very concentrated, and we're going to pour it directly onto the sugar. And what we should observe is actually a black compound being made, and this is the element carbon. It takes a little bit of time for this reaction to proceed. We'll just pour them like that. This is also an exothermic reaction. Heat is evolved in this reaction. It gets quite warm. You can see the initial stage is it turns brown, and gradually it's becoming darker and darker until in fact it becomes black, and the black shows the presence of the element carbon. It may even start to smoke because the heat evolved is quite substantial in this kind of reaction. That's quite cool. As you can see, this is a strongly exothermic reaction, so actually the smoke you see is due to the heat evolved, and now you're left with a kind of clump of black solid. This is actually just elemental carbon.
Carbon in its form of fossil fuels or hydrocarbons have been used for a long time because of the great amount of stored energy it contains. An early example of this is the use of charcoal in steam engines. Carbon in its diamond form is highly valued as gemstones and is also used for cutting, drilling, and as bearings. Carbon as graphite is used in pencils, as rust protection, and also as a moderator for slowing neutrons for atomic fission.